Hey y'all, in this video we're going to be looking at solving inequalities using addition or subtraction. So we want to be able to solve inequalities using addition or subtraction. Taking a look at our big picture, we are going to be solving inequalities with addition and subtraction where it is the same as solving equations with addition and subtraction. So here we have our essential question. This is something you should be writing down. How is solving inequalities with addition and subtraction similar to and different from solving equations with addition and subtraction? So how is solving inequalities similar to or different from solving equations? Let's take a look at this example. We are solving inequalities that involve addition. On the airline that Raul is using, the weight limit for both suitcases combined is 50 pounds. How much can Raul's second bag weigh without going over the limit? So we can see here that one of his bags weighs 38 pounds. So we want to know, is there more than one possible weight for Raul's second bag? Well, if we think about it, that bag could weigh 1. It could weigh 2. It could weigh 3. So there's more than one possible weight for Raul's second bag. So the first step we want to do is write an inequality to represent the situation. Then we'll solve it to find the weight of the second bag. So we know that the weight of the first bag plus the weight of the second bag has to be less than or equal to the weight of the limit, which is 50. So when we go to write our equation, we get the weight of the first bag, which is 38. We'll use P to represent the weight of the second bag, and the baggage weight limit is 50. So we have 38 plus P is less than or equal to 50. Now we'll solve that inequality like we would an equation. So we would draw that line down the middle, and then we're doing things on both sides of our equation. We're subtracting 38 from both sides. We get P is less than or equal to 12. We can also use a number line to show that the possible solutions to this. If you remember from our Desmos activity, we're going to have a closed circle because it could be equal to 12. And then we're shading all of the stuff to the left to indicate numbers that are less than. So if the second bag weighs 10 pounds, the total weight would be 38 plus 10, which is 48, which is less than or equal to 50. So that can help you check that you've shaded the right direction, is plug in one of those numbers you shaded and see if it works. The second bag could weigh at most 12 pounds. And so our answer is that Raul's second bag must weigh 12 pounds or less to avoid going over the limit for both suitcases combined. Here is a problem for you to try. Fill in the correct numbers and symbols. Numbers and whatnot go in the square boxes and symbols in the circular boxes, and then graph your answer on the number line. Our second example is going to solve inequalities that involve subtraction. The weather forecast predicted that the evening temperature could get as low as negative 12.5 degrees. Between the afternoon and the evening, the temperature dropped by 7.5 degrees, which was consistent with the forecast. What could the afternoon temperature have been? And they tell us we want to use T for the afternoon temperature. So again, we'll write an inequality to represent this. Okay, so we have that the lowest it's supposed to get is negative 12.5, and that when we dropped the 7.5 degrees, it met that level. So we're going to do that whatever the afternoon temperature was minus 7.5, so minus the drop, is greater than or equal to negative 12.5. Because if it went lower than negative 12.5, then our low temperature would be lower than that. So it has to be at that or even slightly above it. So we're doing The afternoon temperature, taking away what it dropped, needs to be greater than or equal to negative 12.5. We add 7.5 on both sides because the original problem has us subtracting it, so we do the opposite, which is adding it. We then get T is greater than or equal to negative 5. So the temperature had to, at the very lowest, be negative 5 degrees in the afternoon, but it could have been more than that. We can represent this on a number line as well. We have that dot filled in at negative 5 because we have that or equal to line underneath the inequality symbol, and we are shaded to the right to represent numbers bigger than negative 5. So the afternoon temperature could have been negative 5 degrees or warmer. Here is another problem for you to try that is going to involve subtraction. So we have a speed limit, drops down to 15 miles per hour around a curve. Mr. Gerard slows down by 10 miles per hour as he drives. He never drives above the speed limit. So at what speed was he driving before the curve? So whatever his speed is, taking down that 10 miles per hour, that should get him to 15 miles per hour or below because he never goes above the speed limit. So write that inequality and solve it to figure out how fast he was or could have been going before that curve. Make sure you also graph the solution. And to summarize our lesson here, we have that solving inequalities with addition and subtraction is the same as solving equations with addition and subtraction. We're using inverse operations or inverse relationships between addition and subtraction in order to isolate the variable. So remember that the addition and subtraction properties of inequality are like the addition and subtraction properties of equality. If I do it to one side, I've got to do it to the other side. So I have to do it to both sides to keep it equal. And the only thing that's really different from solving equations is that instead of an equal sign, we have one of our 4 inequality signs. So you can see on the left example, the greater than symbol, and on the right example, the less than or equal to symbol. Your next steps are to complete your practice and then take your mastery check for this lesson. Then continue on to the next lesson. Good luck!